Okay, probabilities of independent and dependent events. So before I can tell you how to do those, we need to define these. So an independent event is when the result of the second event, is not affected by the results of the first event. Affected with an A. Affected. The result of the second event is not affected by the result of the first event. Okay? So conversely, a dependent event is when the results of one event is affected by the results of another event. Okay, so for example, you all know that I'm pregnant and I have this lovely morning sickness to deal with. So, I had a girl, my first child, okay? Is me having a girl, is that going to affect what I have this time?
No.
Those are independent events, okay? Just because I had a girl the first time means nothing as far as what I'm going to have this time, okay? So, those are independent events, right? Formulas, a couple of formulas that we do need to know. And these are actually very simple. They're actually very close to being exactly the same. For an independent event, the formula is the probability of A and B is equal to the probability of A multiplied by the probability of B. That is not a new formula, okay? We've been doing and means multiply all week. Same thing for dependent event. The probability of A and B will be equal to the probability of A multiplied by barely different. This is going to be the probability of B once A has happened, or once A has occurred. So basically, these are changing. The second probability could change based on what happened in the first event, okay? Kind of technical, but it's actually pretty easy, okay? If you look at example, or the given for examples 1 and 2, it says given, I have 3 red paper clips, 4 green paper clips, and 5 blue paper clips. Find the probability of picking a red, then a blue with replacement. So that means I take one paper clip out, and then I put it back, and then pick up another one. So we're still going to use the same formula here, okay? We're still going to use probability of red multiplied by probability of blue. So what is the probability that the first paper clip I pick out of my box or whatever is a red paper clip? How many red paper clips are there? 3 out of a total of what? Add these together, 12. Multiplied by, now if I put that back, what's the probability that I will pick a blue paper clip next? 5 out of 12. I don't care if you reduce first or if you reduce later. Personally, a little bit easier if I reduce first. So that reduces to 1/4. Multiply across the top. 5 over 48. That is your answer. With replacements. That means I did put it back. Same thing for the next one, but without replacement. So that means I did not put it back. So probability of red multiplied by probability of blue. So what is the probability of picking a red paper clip first? 3 out of 12. Same thing. Multiplied by, if I didn't put it back, what's the probability of picking a blue one next? 5 out of 11. Not bad at all. Okay? Reduce those because it makes it a little bit easier. Multiply across the top, 5. Multiply across the bottom, 44. So it is a slightly different probability. Okay, so with and without replacement basically just means if you leave it out or if you take it back. By the way, when we get to questions about candy, okay, there's going to be a lot of questions about, like, if you take out a something colored Skittle or if you, stuff like that. If it's asking you, like, if you eat something, does that mean it is with replacement or without? Without, okay? If you ate it, you can't put it back. It's not like my morning sickness where I can eat it and then put it back, okay? No. So just FYI, when we get to the ones about the candy, think about it. If you ate something, we are not putting it back, typically, okay? For number 3, we're going to be using tree diagrams. Yeah, whatever. Okay? Tree diagrams. So, for tree diagrams, I wrote these out because they're kind of long and it takes a long time to write things out for you. So, for number 3, a flight is sold out and all passengers arrive and have boarded the plane. The seats in the plane are 15% business class, which is a fancy way of saying first class, and 85% economy class, which is a nice way of saying you're in coach. Of the passengers, 70% have carry-on baggage, 30% did not carry on luggage. First, we need to complete the tree diagram. So, you get on the plane. Okay, when you first get on the plane, you are either sitting in which 2 options? Business class or economy class. Okay, so business and economy. You may write out the whole word if you want to, but I don't want to. Okay? Then, our next option is what? Carry on or not. So, we either do have luggage, so we have no luggage, or you do have luggage. What about for the economy people? What's their next option? Same thing. So no good luggage, or they do have luggage. So these little diagrams, these tree diagrams, will not be written out for you. You probably need to make a picture. Okay, so just draw a quick little tree diagram and then fill it out. Now let's fill in the statistics that I know. How many people are in business class? 15%. Now, keep in mind, I want to write these in decimals. So 15% in decimals is 0.15. How many are in economy class? 0.85. Now, notice that these are complementary. That means they add up to be 1. They have to equal 1. Okay, people are either in business class or in economy. There's no one anywhere else. Okay, there's no one like being a stowaway. They're either in business class or in economy. Then,
is it leaving from Cuba?
We're talking about the passengers. It was specifically said passengers. Thank you for trying. So, luggage or no luggage? How many people have luggage? 70%. So 0.7. If you'd like to put 0.70, that is fine, but just 0.7 is also fine. Luggage is 0.30. So again, complementary. You either do have luggage or you don't. Okay? Does not matter either way. Did I mix these up? I'm sorry. I'm sorry. So 0.30, 0.70. I'm sorry. So no luggage is 0.30. I'm bad. I'm sorry. 0.70 does have luggage. I want to find the probability that a passenger selected at random will be sitting in business class and will not have carry-on luggage. So take your pencil, whatever, highlighter, I don't care. You want to follow the branch. So we are going to follow the branch that is sitting in business class and will have luggage. So business class, luggage. So you take those two probabilities, probability of being in business class multiplied by the probability of luggage.
Wait, I thought it was one.
Oh my god. Well, not. Dang it. Okay, you know what? This brain is not working today. I'm sorry. I should have, but sorry. So,
just blame it on the morning sickness.
no luggage. It's, you know what? Yeah, it's the puking. So, probability of being in business class is 0.15 multiplied by probability of no luggage is 0.3. When you multiply those together, what do you get?
0.045.
Okay, let's think about this. When we multiply decimals, you have to count the decimal places. 0.045. If you do not count the decimal places, you're probably going to get it wrong. So, 1, 2, 3 decimal places, 1, 2, 3 decimal places. 0.045. If I asked you, which I'm not, but if I asked you, what is that as a percentage?
4.5%.
4.5%. Okay, so key here is follow the branch. Follow the branch. Say it again.
There's a 5% chance of getting it right.
Okay, follow the branch. Yes.
No, do we have to draw the diagram?
Yes. You need to draw the diagram. Just draw the diagram. There's not that many. Just draw the diagram. Okay, for number 4, you have just won a new car. We're on a cool game show. You have just won a new car. I'm so proud. It is either a Mustang or an economical Prius. Awesome. Okay, 30% of all Mustangs have automatic transmission. 90% of all Priuses have automatic transmission. I know that's a lie because I don't even think they make Priuses with manual transmission, but whatever. Okay? Get over it. It's fine. If there is a 0.675 chance that your car is a Prius with automatic transmission, what is the probability that you won a Mustang? This one's a little backwards. Okay, so we want to fill in our chart. So you're on the game show. You either won what? A Mustang or a Prius. From here, what is your next choice? Automatic or manual transmission. So automatic, I'll even write out the word for you, or manual. What's my choice for Prius? Same thing, automatic or manual. Now let's fill in what I know. Okay, I know that 30% of all Mustangs have automatic transmission. So Mustang's automatic is 0.30, 30%. So how many have manual transmission? 70%, so 0.70. These are complementary, okay? They have to add together to equal 1. How about for Priuses? 90% of Priuses built have automatic transmission. So 0.90, how many would have manual transmission? 0.10 or 10%. Now, I am telling you that there is a 0.675 chance that your car is a Prius with automatic transmission. So if you multiply these two branches together, it equals 0.675. So I'm not giving you the branches, I'm giving you what they multiply to be. So if I want to find the probability that you won a Mustang, first I have to find the probability, or first I know that the probability of being a Prius and automatic is equal to 0.675. So if I multiply these together, I know that the probability of a Prius multiplied by probability of being automatic equals 0.675. Can you fill in the blanks here? This is a 0.9, so how do I solve for probability of being a Prius? Divide. Probability of a Prius is equal to 0.675 divided by 0.9. I used my calculator. This is 0.75. Therefore, the probability of winning a Prius is 0.75. What is my question asking for? Probability of a Mustang. How do I find that? They are complementary, so if it's 75% Priuses, what would be Mustangs? 0.25. Okay, so you have to use the complementary things. Okay, you have to think about this a little bit. So you might have to go backwards. You will have questions like this on your test and on your quiz tomorrow and on your homework tonight. Okay, last one is called conditional probability. Okay, conditional probability. Conditional probability is the influence of one event on another. Okay, so the influence of one event on another. What we're going to be talking about in this example is people that have a job, so people at a workplace. How many of them have college degrees? How many of them don't? Do you think that having a college degree will influence your chance of having a job? Yes. Yes. Okay, plain and simple, conditional. So, the formula for conditional probability is the probability of event B given event A. Now, we're in math, and so we like to write things, with some abbreviations, so I'm never actually write that out. That's written as probability of B, this big line that says given A. Probability of B given A. And that is equal to probability of A and B divided by the probability of A. So it's always divided by the second one. This is a super important formula. You need to memorize it and know how to use it. Okay, so we say at a business, 7 men employed are college graduates and 12 women employed are college graduates. There are 2 men that did not graduate college and 3 women who did not graduate college. What is the probability that if you randomly pick an employee, it will be a female given that you picked a college graduate? So we need to fill in this chart, okay? The first chart, or the first question we have college graduates, so college grads, and not college grads. Now, these charts will not always be written out for you, so you might have to draw them, okay? We also are going to have a table or a spot for total. What are my other factors that I know? Men and women. Men, women, and again, I'm going to have a spot for total. So now let's fill this in. How many men are college graduates? 7. How many women are college graduates? 12. So how many total college graduates do I have? 19. Okay. How many men are not college graduates? 2. How many women are not college graduates? 3. So how many total non-college graduates? 5. Now, we filled out these totals, but you also need to fill out these totals. So how many total men are there? 9. How many total women are there? 15. Now, these two totals, so the horizontal and vertical totals, must be the same, are they? 24. So we have 24 total people. If these do not line up and not equal the same thing, you made a mistake somewhere. So you got to check. So I'm going to find what is the probability that you pick an employee that will be female, probability of being female, given, so that line, they are a college graduate. Probability of being female if they are given to be a college graduate. So according to my formula up here, what should be in the numerator here? Probability of what? A and B. I don't want numbers, I want words. A and B is what? Female and college grad. Divided by probability of which one? Being female or being a college graduate? College graduate is always the second one. Okay, it's always the one after the given. So it's always the second one. So being a college grad. No, I didn't. Probability of the second one. Probability of A. A and B divided by probability of A, which is always the second one. You don't need to switch the A and the B.
No, she didn't. It's weird.
It's just confusing because you say the second one, but the first.
It's written right. It's just an interesting formula. It's a different formula. So, how many females are also college graduates? Out of my chart, how many females are also college graduates? 12. 12 women that are also college graduates. Divided by how many total college graduates are there? 19. That is your answer. Okay? So if you fill in the chart right and make sure you fill in the totals, because the totals are important, it's easy to just pick the numbers out and plug them in. Okay? Homework for this is going to be worksheet 5. You are doing numbers 1 through 20. So worksheet 5, numbers 1 through 20. Okay?